Assalamu alaikum students. In this short video, we'll be learning how to differentiate the function sine of x by using the first principle method, right? So I'm going to suppose this sine x as the function of x. So if I say f of x is equal to sine of x, to find the derivative by using the first principle, we need this formula, right? Which is f dash of x, or the derivative of x, is equal to limit h approaches to 0, f of x plus h minus f of x over h. Here h is the smallest change in x, right? And it approaches to 0. Okay, so we need this f of x plus h. Got it? So finding this one, f of x plus h, replace each x in the function by x plus h, so it becomes sine of x plus h. Got it? Now I'm going to put this whole thing in the formula, but before this, I need to find this difference. So this difference is f of x plus h minus f of x, which will be equal to sine x plus h minus sine of x. So to simplify this whole expression, I'm going to use this identity, this one. There, we states that the difference of the angle sine alpha minus sine beta is equal to 2 times cos alpha plus beta over 2 sine into sine alpha minus beta over 2. So using this property here, the alpha is x plus h and the beta is x. Got it? This is alpha and this one is beta, right? So this will be replaced by 2 times cos alpha plus beta, means x plus h plus x over 2, right? Into sine of alpha minus beta, which is x plus h minus x over 2, right? So here, this is alpha, this is also alpha, and this x is beta. Okay, now I'm simplifying it. We get 2 times cos x plus x is 2x plus h over 2. And here, the x cancel with this negative x. So we're left with sine h over 2, right? Okay, to simplify this, we have another identity. It is sine x over x. If x approaches to 0, it is equal to 1, right? So this identity will be used here. So first of all, we'll need to make h over 2 in the denominator of this sine h over 2. Clear? So to do this, I'm going to write this cos 2x plus h over 2 as it is. And this 2 becomes the denominator of this. And it can be written as 1 over 2. So we are left with sine h over 2 over 1 by 2. Right? Till we need h here. So now I'm putting this whole value in the actual derivative function f dash of x. So f dash of x is equal to limit h approaches to 0. And this is f of x plus h minus f of x. And this value we have already found. It is cos of 2x plus h over 2 times sine h over 1 by 2, right? And then divided by h as well. this h. Now I'm applying the limits. I'm going to apply the limits for individual functions. The first function is 2x plus h over 2. Applying the limit for this interval for this function, and then limit h approaches to 0 on the second. The second function is this whole thing, including this h, right? Limit on sine h over this 1 over 2 times h will be h over 2. Clear? This is sorry h over 2. So now using this property, sine x over x, limit x approaches to 0 is equal to 1. So which means that this whole thing will be equal to 1, right? So apply the limits here. This will be cos 2x plus 0 over 2. And this whole thing is equal to 1, right? So finally cos 2x over 2, which is equal to cos of x. So this one is the derivative of sine x by using the first principle. Hope you understand this video. Take care. Allah Hafiz.